In this video, we're going to talk about one really big, important concept of calculus, and that's L'Hopital's rule. All right, so L'Hopital is just some French dude. He got this rule named after him because he created it. All right, so remember this. When we were first learning limits, we have a limit that looked like this. All right, limit as x approaches 2 of x minus 2 over x squared minus 4. All right, how did we solve this? Well, we solved it by factoring. I'm just going to do it really quick because it's not actually that important for what we're doing. Canceling out factors. And then once it gets out, we could plug in, we get 1/4. All right, so that's how we did this problem before. A lot of algebra. We also had to do conjugates and things like that. But there actually is an easier way to do this type of problem, and it's called L'Hopital's rule. All right, so here's what L'Hopital's rule says. I'm trying to find the limit of a fraction, f of x over g of x. If either of these things happen, I can do L'Hopital's rule. If I look at the limit of the top and it's 0, and the limit of the bottom is 0, all right, so that's option 1, or both the limits are infinity, so either they're both 0 or they're both the complete opposite, they're infinity, then instead of taking the limit of these functions, I can find the limits of their derivatives. And here's one kind of confusing thing. You're not taking the derivative of this whole thing, so you'd have to do the quotient rule. You're taking the two derivatives separately. So it's still a fraction involved, but it's not doing the quotient rule. So a little confusing, but we'll look at that. All right, so in other words, if both parts of the fraction are 0 or infinity, we take derivatives and then retry the limit. All right, so here's the exact example we looked at. In that first example, we know the answer should end up being 1/4, but let's just make sure it does using L'Hopital's rule. All right, so the first thing we have to do is double check the limit as x approaches 2 of x minus 2 is 0. All right, because it's 2 minus 2. All right, the limit as x approaches 2 of x squared minus 4 is 2 squared minus 4, which is 0. All right, so both these limits are 0. So now we can say this is equal to, using L'Hopital's rule, the limit as x approaches 2. The derivative of x minus 2 is just 1. The derivative of x squared minus 4 is 2x. And now for this limit, there's nothing bad that can happen. I can just plug in 2 and get 1/4. Okay. So no algebra involved. It's just plugging in numbers, taking derivatives, and I get the same answer, 1/4. All right, but here's the thing with L'Hopital's rule, especially with the AP exam and how particular they are with how you use L'Hopital's rule. All right, you would need to separately show that the limits of f and g are 0 or infinity. I do not do this. All right, so let's look at this example again. If I had this limit, I don't say this limit is equal to 0 over 0. You want to say that because the top is 0 and the bottom is 0, but they hate this equal sign with something that's not actually equal. All right, so don't do that. Write these limits separately and then say you're going to apply L'Hopital's rule. All right, and then show equality and calculate the new limit. All right, so this is the exact way you would have to do it to get full credit on the AP test. For the free response part, multiple choice, you can do whatever the heck you want. All right, so here's another example. All right, limit as x approaches 0 of sine of x over x. If I want to use L'Hopital's rule, I'm going to check the limit of the top function. Again, kind of to the side. That's sine of 0, and sine of 0 is 0. All right, limit as x approaches 0 of x, that is 0. All right, so I get 0 over 0, so now I can do this equality using L'Hopital's rule. The limit stays, but now I take the derivative of sine is cosine. Oops. The derivative of x is 1, and I can just plug in 0 now and get 1. So the limit of this function is 1. All right, so here's one for you to try on your own. I find the limit of this function. All right, make sure you're writing out the steps necessary to get the credit for the AP test. I'll show you the answer in 3, 2, 1. All right, so the first thing you should do is just work to the left in green. The limit of the top is 0. The limit to the bottom is 0. Since they're both 0, you can do L'Hopital's rule. Derivative of 1 minus cosine of x is going to be positive sine of x. Derivative of x is 1. And since there's nothing weird happening in this one, I can plug in 0 and get sine of 0 is 0. All right, so that's the answer for this problem using L'Hopital's rule. But again, it's really important you write this stuff in green, kind of to the side, say you're using L'Hopital's rule, and finish there. All right, there are other, what are these called, indeterminate forms. 0 over 0 doesn't quite make sense. Infinity over infinity doesn't quite make sense. That's why they're called indeterminate forms. We don't know what they're going to be. All right, but there's other ones that apply to L'Hopital's rule. We're just not going to learn them because they're not on the AP test, and it'll take another 2 classes or something to learn. So we'll focus on the ones on the AP test for now. All right, so here's the summary. All right, L'Hopital's rule, make sure you show the 2 limits separately of the top and bottom. If they're both 0 over 0 or infinity over infinity, then you can do L'Hopital's rule, and I meant to write quotient rule here. Even though there's a division bar in the problem, you're not doing the quotient rule, you're taking these 2 derivatives separately, which is kind of what you wanted to do before you learn the quotient rule. Just remember that there's a difference between taking the whole derivative and applying L'Hopital's rule.